Hi, I'm recording this video to have a separate video on the ggplot2 tutorial, which is just a very important topic for data visualization in R. So I thought it would be useful to also have a video on this topic. So in R, there are multiple ways to do data visualization. R is very powerful in data visualization, and mainly they boil down to two different ways that you can use, can make plots. The first one is all the methods that come with R itself, which we call base R. So if you install R without using any packages, it has plotting methods in there. They are very, very powerful. You can use the plot function to make a scatter plot, or points or lines to add points or lines to that, or you can use bar plots. There are lots of methods in R already. They're really flexible. The nice thing about them is that you make a plot and then you can add stuff to them. So if you want to add some text somewhere, it's very easy to make the plot and say, okay, now add text there. Or if you want to add a line somewhere, that's very easy to do. They're also so flexible that you can actually make all kinds of interesting extensions. So for example, I made R packages, make networks and path diagrams using base R plotting. The downside is that they use quite a lot of code and that it's quite hard to do data visualization, which means that for some plots, you just kind of need to have some things in there, like a legend, and it's a bit harder to do that with base R in a nice way. And for that, the ggplot2 package is a very popular method for making plots that are really designed to visualize data. ggplot2 is based on grid, and grid is a different way of plotting than base R, so they're not really compatible with each other. You can't really make a base R plot and then add ggplot2 to it. But both are very strong, very powerful, and you'll see many people use ggplot2 only, or they really rely on it to make their plots. Now, I'm going to teach ggplot2 in this video. I'm not going to teach base R. It's a very different set of methods. This video is designed for data visualization, for data science. But if you're more interested in just making pictures in R or making graphics, then definitely check out base R as well. So here are two examples. Both are from a paper that I co-authored with Dadis Varanu and Mike Chong. And in that paper, we actually used both base R and ggplot2. For example, on the left here, this is an image that is made with a package called qgraph, which I made, that uses base R to make a network. These circles here represent PTSD symptoms. These lines here represent strength associations. The thicker line means stronger association. And this is actually just a base R plot where we have here a scatter plot with lines drawn between them. That's really the core idea behind this qgraph package. On the right here, we show the confidence intervals around these estimates. This is an estimate. It has an interval, a confidence interval of uncertainty. And for that, we use ggplot2. There are lots of things in here that would be very hard to do in base R, like these labels nicely, the different colors of the intervals, the legend here, the background grid lines, the nice scale here. Those things would be very hard to do with base R, but very relatively easy to do with ggplot2. So just to show that it's not like a black or white situation that you have to pick one or the other. You can use both, and they both have their pros and their cons. All right, let's talk about ggplot2. So in ggplot2, we need to make a plot. To do that, we first need to understand the basics of a plot, or what is a plot. So in a plot, we can represent the values of variables that we have in different ways. And this is something we need to think about. Let's say we have a data set with a variable like x and y, or like the independent variable and the dependent variable. Maybe we have social media usage and happiness, for example, and a third variable, gender, for example, and a fourth variable, age. And we want to kind of make sense of this. How much does social media usage impact your happiness, depending on your age and your gender, stuff like that, right? We first need to think about how are we going to represent our variables visually. So for example, we could choose to represent the variable by differing it horizontally. So let's say we could put social media usage horizontally and say if you are using social media not that much, we put you on the left. If you use social media a lot, we put you on the right. on the X location of a graph. We could choose to put happiness vertically, right? The higher you score in your happiness, the higher your point will be on the plot. Yeah. We could also use other things to represent variables, like we could use color, for example. So maybe we want to make points and we draw like with the color we indicate how old you are, with like a darker shade meaning you're older and a lighter shade meaning you're younger, for example. Or maybe we have a line plot and we want to use different types of lines, like dashed lines or dotted lines or different colored lines. Or maybe you want to change the size of a point in your graph to indicate your age or anything else. Lots of things we can do to represent variables. This we need to choose is the first thing we need to choose when we use the ggplot2. These are called aesthetics. In ggplot2, so ggplot2 is the package, ggplot is the function in the package that we use. We first set the aesthetic mapping of our data using the AES function inside ggplot. So the AES function stands for aesthetics, and it's used to set a aesthetic mapping in the ggplot function. The aesthetic mapping tells us how are we going to use variables, how are we going to represent them. For example, horizontal placement, vertical placement, etc. After we define the aesthetics, we need to then define how we're going to use the aesthetics to actually make a plot. So we need to define how these aesthetics are used and what we are plotting. We do this with something we call geometrics, or short geom, G-E-O-M. For example, we might have lines or points or bars or box plots or curves, right? So a line is not representing a variable per se. A line is representing values, like the height of the line is representing a variable. The color of a line is representing another variable, right? The line is just a line. These are geometrics, or geoms in short. And these we can add to the plot using plus. It's a bit of a weird notation because plus you normally use for adding, right? Like 1 plus 1. But in ggplot terms, we can also use it to add stuff to our existing plot. In the ggplot2 documentation, it says that the aesthetic mappings describe how variables in the data are mapped to visual properties of the geoms. Right, so a geom might be a line, and it has visual properties. It is like high or low, it is red or blue, it is dotted or solid. Those are representing the variables. It's a bit weird, but once you see the code, it will make a bit of sense. So let's look at some example data. This is just some R code that will generate some random data. Like, you don't need to understand this, but the data looks like this. It has like hundreds of lines of code, actually 100 lines of code because I have 100 here. 100 people, different gender, and they drink coffee and have a heart rate. It's made up data, so it's not really accurate, but basically we can look at the relationship between how much coffee you drink and your average heart rate, depending on the gender. Now, we first need to load the package library ggplot2, and then we can use the ggplot function to start making our plot. So we say ggplot, the first argument is the data we're using, and the second argument is this aesthetic mapping. It can be pretty big. You can use new lines if you want. AES, and then the aesthetic mapping here. X, which stands for horizontal placement, equals, and coffee is a name of a column in the data frame, right? Coffee. Y, which stands for vertical placement, and heart rate, again, a name of a column in the data frame. We do that, then we get this nice plot. Actually, that's a lot already. It puts like a label here, some x-axis, some y-axis, but it doesn't actually do anything yet. And why not? Well, now ggplot knows that you want coffee on horizontal placement, heart rate on vertical placement, but then what? It doesn't know what you actually want to do here. So for that, we need to add geometrics. So we can do that with this weird notation where we say plus, and then we say geom point, and we say open bracket, closing brackets. There are some arguments we can put in between, like the size. We can say size equals and something to make it bigger or smaller. We can also leave it and have no arguments. We can just say geom underscore point. with open bracket, closing brackets. Now, the ggplot will know what to do. The ggplot will know that we have this data, we have this aesthetic mapping, and we add this geometric, this points. It will know to draw points. And I can add a third variable by simply adding something to the aesthetic mapping. So here I add color. By adding color, the ggplot automatically makes a legend. It automatically colors some of the points with 2 colors, which is just very nice. That it does all these things automatically. Actually, you'll see it makes the plot a bit smaller to make space for the legend as well. All we added here is color equals gender, which is again a column in our data frame, this one. Now what do I do here? I switch the X and the Y placement around. So I put heart rate on X, coffee on Y. And you see it will automatically just put heart rate on the X-axis, coffee on the Y-axis. Now, there are no real laws on what you put on the X-axis, what you put on the Y-axis. Typically, in psychology, you put your dependent variable on the Y-axis, your independent variable predicts on the X-axis, but you don't have to, right? The main thing you want to do is to make a clear plot. So let's say if you have a lot of horizontal space for your plot, not that much vertical space for your plot, like a wide infographic, for example, you might want to choose to put the variable with the most variance on the X-axis and the variable where you only have a few things on the Y-axis. Right, so maybe this would make more sense because heart rate goes from like very low to very high and coffee only goes for like a few values. Here I put gender on the X-axis. And in this case, I made a very simple data set with only 2 levels here. I put heart rate on the Y-axis and I put color on the color, coffee on the color. Right. What you see here is very interesting. Gender, which is encoded as a categorical variable, right? It's not numbers, it's like letters, gets distinct colors. But coffee, which is encoded as a numeric value, gets a gradient. A very different type of legend and a gradient, which is nice. Now, we might not want that because we have actually fixed values for coffee, 0, 1, 2, 3, 4, 5. We could make it a factor using the factor functions. And then actually with the levels, we can define also the labels that we get here, if we want. We could say levels equals, well, 0 to 5, then labels equals, and then rename it according to the levels. And then we get a categorical legend here. Now, this is not that nice, right? It's a bit, hard to see. So maybe we want to use something else. Or maybe we can use something we call box plots. So note that all I'm changing here is this command, the geom from point to box plot. And it automatically makes something very different, puts it next to each other, which is quite nice. It's already nice graph. Now, here I use the color aesthetic. I can instead use the fill aesthetic. Right, so that's the only thing I do different here. I added some spaces here, but that's not important. The fill aesthetic to make the outline black and the fill instead colorful, which I like a bit better for box plots. Now, what is a box plot? You might ask. A box plot is a very powerful way to visualize a range of numbers. It visualizes the distribution where we have this box. The dotted line is the median. So that's the, if you order all values from low to high, the midway point, like the most medium, the most average response you got. Not the average is in the mean, right? But if you order from low to high, like really the center. And then we have the 25th percentile, 75th percentile. This means that 50% of your observations are in this box. If you order from low to high, then the 25th percentile is literally the value you get at the 25th percentage of your values. And the 75th percentile is the value you get at the 75th percentage. And then the whiskers of this box show you the range from the minimum to the maximum value, unless there's some outliers which are shown as dots. What are the outliers? You can look at that in the help file because there's some different rules for that. But yeah. There are some ways to define if something should be drawn as an outlier or part of the range. Mostly this shows that all the values are here, except for these few that are a bit higher. Right, so what does this show me? It shows me that for the women, the heart rates of the people that don't drink any coffee is here. It's not realistic, of course. This is made up data, right? I hope that this is not like that high on average heart rate, but right, it's just to give an example. So what do I do here? Same thing, I have the G on box plot, but I changed a few things here. I added the label with xlab, this one. I added the label with ylab, this one. And I used scale underscore fill underscore discrete to change the label of the legend. Right, so here it says this ugly factor coffee, and now it's nice just coffee. Here I use what we call a scale function in ggplot2, and we have a lot, and they all structured in the same way, which is quite nice. It's scale underscore the type of aesthetic to which scale applies, like fill or X or Y or color or shape, underscore, and the type of variable, like continuous or discrete, or you can write manual in case you want to really define something yourself, like the exact colors you want to use in your scale. And in this function, you can set anything like the colors that you use, but also for the x-axis, the range, the bounds, the lower bound, the upper bounds. These lines here, these grid lines, are called breaks, and you can set them as well with the scale underscore x underscore continuous function, for example. So everything that relates to one of the scales used, you can use with these type of scale functions. Now let's make this nicer. So what I do here is I add team underscore BW, black and white. I like that better than the default. So the default is this grayish background. I find it very crowded. I like this better because it gives this nice black border around the plot and this lighter, less distracting grid lines. But you can actually ask yourselves, are these grid lines needed? Like especially here, this vertical grid line is a bit pointless because it's only showing the midpoint. It doesn't show anything for these. We can remove them as well. But this team underscore black and white makes this nice theme. And then we can change some things. So what I do here, I just change the aesthetics around again. So now I put coffee on the x-axis and I put gender on the color and the heart rate on the y-axis. Same data, but represented differently, different emphasis point. Right here I see really the relationship from coffee on heart rate as this mediated or moderated by gender. You can also use this geom smooth. So now I'm back to points, scatterplot, and I use this smoothing splines to show a bit what the trend is, which automatically comes with this error bar around it. We can make that, so this is an error bar basically based on smoothing splines, and the plot is like smooth, right? We can make linear regression with method equals ln to just make straight lines. And we can also remove these error bars if we want with se equals false. That usually gives a more clearer picture. Usually this shared error bars are informative, but is it really the message you want to communicate in this case? If that's just there's a positive trend, I don't think you need them that much in this plot. I think you say se equals false. And that's just to show that you can do a lot of flexible things with actually not that much code. Like doing this with base R would be at least 20-30 lines of code. So that's quite nice that this is all easy to do with ggplot2. Now this is another method that I like called facet underscore grid. And the interesting thing here is that it will use a variable or two. So now I use this dot because I don't have one for horizontal facets, but you can use another variable here to make different plots, which is extremely powerful because you can make a different plot for gender in this case, female, male. And we can also make different plots horizontally. So we can make a grid of like one variable by another variable and get all the small plots there, which is something that definitely is very hard to do in base R, but it's very easy to do in ggplot2 with just this facet underscore grid function. I use it a lot because it makes it very easy to look at many variables at the same time something on the x-axis, something on the y-axis, something on the vertical grid, something on the horizontal grid, then maybe something with color. You already have 5 variables interacting with each other. All right. Now, ggplot2 has something called themes. The theme is defining how the plot looks like. And you can add a theme function with the theme underscore and then some name. These are the full themes. So they already have like some particular setup. Like for example, theme black and white will always look a bit like this. Theme classic, another very nice one. We'll just create is like more like classic-like plot that you might want to use in your academic paper, right? Straightforward, no grid lines. I like that because are these grid lines really needed here? Like here, for example, do we need these vertical grid lines? I mean, not really, right? We see that the bar is here. We don't need a line to show that, right? So with theme classic, you can get rid of that. There's some other ones as well. But you can also make a custom theme yourself with the theme function. Let's take a look. So here we have our standard scatter plot. And then I add theme black and white. And you see a lot of changes, right? Or a lot of changes. Theme classic is this nice, more classic-like standard type of plot. As I said, you can also define all these things yourself. You can use this theme function and you can go as wild as you think. Like literally anything you see in this plot can be changed the way it is shown. The color, the size, the font size, if there is a grid line or not, the box, right? All these things can be changed. You can do it with a theme function that has a lot of arguments and it's always very hard to figure out what they are. So for that purpose, Google is like amazing. Like I always Google how to rotate something in ggplot2. Many people asked the question before, so you can find it online. More recently, AI is also very good at this because it's been trained on many people asking these questions before, right? So it will give you the same response and it will usually give you quite a good response as well. At some point, you kind of get the hang of it, how these arguments are called, like panel.grid.major is the grid line, for example. But if you want to change anything, I would just strongly recommend just Google and try things out. And so here, for example, I say the plot background element rect means a rectangle with a certain fill, certain color, and it changes the way that the plot looks like. What I did now is I made the plot this. Like I changed everything. I changed the color here, I changed the background, I changed the grid lines, I removed the horizontal grid lines. I'm not sure if this is actually an improvement of what we had before, but it's different, right? So if this is the style you're going for in your infographic, for example, then sure, you can do that. This one actually got from this really nice R bloggers post on how to make an infographic completely in R, which is pretty cool. But if you do want to make an infographic, for example, in the project in PL445, I would not recommend following this guide fully. I would just recommend following it for ggplot and then using some other software to make the design like PowerPoint. Okay, so let's talk about saving ggplot2 plots. So once you made a plot, you of course want to save it, to use it in your paper or maybe an infographic or on your website or whatever you want to do with it. So how do we do that? Well, the general structure of ggplot2 is you have ggplot, we have some stuff in there, namely the data and the aesthetic mapping, plus and a lot of stuff like geom, point, theme, scale, x, continuous, whatever. Right? We can save that into an object. I usually call it P, but you can really use any name you want. After that, we can make the plot with the print function. Now this is interesting. This only works for ggplot2. You can also use plot, but historically people use print for ggplot2, but you can't actually use print for any other plotting method in R. So that's a weird thing, but you can write print P to make the plot. Now, if you want to save a plot to a file, a ggplot, what we can do is we can open a device, a graphical device, with a function like PDF. PDF works very well for our plots because it's vector-based, which means that basically the PDF stores like the points and lines and not the pixels. We can open a PDF, give it a name, file name.pdf or plot.pdf, whatever. Define a width and a height, usually in inches. Now, I'm European, I don't know what an inch is, but 7 is usually pretty good. But if you want to make wider, then I usually use like 5 for height and 8 for width, something like that. Then if you do this command, we open the device in R. Then any plot we make is not sent to the console, it's sent to this plot. So it opens a file, and anything is written to that file. And with dev off, device off, we close the file and we basically finish it up so you can actually open it on your computer. If at any point you don't see plots appear in your R in window anymore, just run this command dev off many times, because maybe sometime when something went wrong and you open multiple devices and it's trying writing into 3 files, and that's why you're not seeing a plot anymore. There are many different graphical device functions in PDF. So I tend to use PDF, which is really good. The only downside of PDF, it doesn't work well with other programs. Like to import a PDF into PowerPoint or Word doesn't always work well. It works great with LaTeX documents. If you program or write in LaTeX, then PDF is definitely the way to go. But yeah, if you write in PowerPoint or Word or something like that, or you want to use your image on a website or just put it on Blue Sky or Twitter or whatever, PDF doesn't work at all. There's a function called PNG in R to make a PNG file. It is one of the best formats to make an image, a raster-based image, basically an image stores pixels, which is a bit easier to use in other software usually. But the PNG function in R doesn't work that well. I find that it creates very ugly pictures on very large file sizes. And I prefer to use the Cairo package, which makes much better PNGs for much slower file sizes. This does install that Cairo is installed in the computer, so you can go to this link to try to install it. It's not always easy. It depends a bit on your computer. Another option is TIFF. It can create high resolution raster images, but it does require a large file size as well. There's one more option that I'll show in a bit that we can use in ggplot, which is called ggsave. So the graphical device can also control the size of font size. Basically in the PDF function, you can say, okay, I want the font size to be this, those kinds of things. And as I said before, if nothing works in R anymore, use dev off a lot of time. Like if you don't see plots anymore, until you get an error, then it should work fine again. Right, so this is a way that I usually store PNG files. I make a plot, I open the device, in this case a Cairo PNG. A PNG made by Cairo is a width of 10, a height of 6. I use inches as unit, and this DPI stands for the resolution. I want it to be 300 or so it's good, nice picture. I plot, and I use dev off to close the device and make a picture. Now, ggplot2 actually has this ggsaves command, which does work really well. I find it works much better than the PNG function in R. I don't know how, but it does. You don't need to have Cairo installed, so I can also definitely recommend using this. It only works with ggplot objects though. So we have to give a name. We have the object, the ggplot object, the width in inches, the height in inches, and the resolution. I definitely recommend that you use this if you have ggplot2, if you don't want to install Cairo, and if you don't want to have a PDF. Now, here's a small trick that you can also make a plot with a transparent background. And that can be used useful if you want to use your plot in other things. Like for example, you want to give a presentation, you want to have a plot in there. You want your plot to nicely merge with the slide layout. We can make a plot with a transparent background by using this theme function in ggplot2 to make a transparent background. And actually, I see here, because I compiled these slides in PDF, this should be a normal tick mark or a double tick mark, not this weirdly stylized tick mark. But that's a weird thing about the PDF. Now I'll show some examples of how to do this now in ggplot2. All right, so here we are in R. And I load 2 packages, the dplyr, I always load it, ggplot2. I generate some data, just some random data. Let me put this a bit higher. I generate some random data, which looks like this. Get the space here. Just gender, coffee, heart rate, It's not real data is generated. Then I can use the ggplot2 to make my plot. This would be a very basic plot where I just have the scatter plot. All I'm saying here is use this data, map coffee to the X, map heart rate to Y, and make points. And we get this plot that I already showed you in the slides. Right, and we can add color is gender, for example. Yeah, gender, let's do gender. We can create this. Right, we can also use American spelling, it's the same, but actually for a very long time only British spelling was used in ggplot2 as far as I know. So that's why you'll see much code examples still use British spelling. It doesn't matter. Now we can do all these things that I showed in the slides, like add theme, for example. Like I can make this theme classic, which is a nice thing to do, right? To make it classic, or theme black and white, make it black and white, and maybe I want to remove the grid lines. So panel grid major. This one is element blank. And then all the major grid lines are removed. Let's also remove the minor grid lines. Minor. And now there are no grid lines. You might have noticed actually some stuff appearing. That's because I have AI suggestions. Tools, global options, Copilot. I have an AI Copilot installed here, which you have to pay for, but it's from GitHub and it's actually very useful for this kind of stuff. So rotate X label. It will just give me AI recommendations that tend to work pretty well, which is just amazing. Now I want to show this trick where I have a transparent background. So I have this plot, to make it transparent background. I can look at this. Right, and I see here that I actually made things transparent. Doesn't show so different here, but the plot will be transparent. Now, what I can do is I can save this with gg save to make a plot with a transparent background. Now, why is it useful? For example, I could go to PowerPoint to make something like an infographic, or I might have like slides, you know, and I have a presentation, or I might want to make something else. Right now I have here, it's a picture that I got from the internet, and that's insert the picture that I made, and you'll see that it nicely blends with the slides, right? It doesn't have this white background. Otherwise it would have a white background and it would not be able to put it nicely here. Now this is kind of ugly, right? So let's make it a bit nicer. So here just add the theme classic. That is the only difference here. And make the second one here, which is already nicer in this case. Right, so I have here no grid lines in the background, which is much nicer if I want to blend it with the background here. Right, so this already looks like a nice infographic, but there's much more that you can do in ggplot2. There are actually some really advanced tricks you can do. So I'll just run this code. I'm not going to go through it in detail because this is pretty advanced stuff that I do here. I make like some error bars, right? Lots of dplyr stuff. I group by coffee factor, make error bars here. Then I send it to ggplot2, and I use this error bar geom as well. And I actually also, let's make this a bit bigger so you can see the entire code. I use this chord polar, which is really cool because it makes a circular graph rather than a horizontal graph. So let me just show you what it does. It makes this plot here, where we have this round. The x-axis now circular, which is really cool. I use a gsave. You see that I don't use the plot is equals here, notation here. It will automatically save the last plot. So now I can go to insert, pictures, picture from file. And I add that, this one here. And I have a really cool, nice infographic here. Of course, this is not really the most spectacular design yet, but it's already something that is actually pretty remarkable that we can do. Now you can make these type of background stuff in R. It gets pretty tricky to do that. So I recommend that you use ggplot to make that, and then use some other software like PowerPoint or Canva or anything that you like to make some design around that in case you want to make some infographic or something else. Even for academic papers, sometimes you can get with ggplot2 90% of the way where you want to be, but not fully. You might want to add some annotations, and it might be too tricky to do in ggplot2. Then again, it's an easy trick to export it, import it in PDF, PowerPoint, do the rest there. Okay, so that's it for this tutorial on ggplot2.